Okay, we have a figure here of multiple triangles. What we want to do is, by using the exterior angle inequality, we want to find out which angles are bigger than other angles. Okay, and so basically this is just a sample of pulling together several things. Let's come over here and let's call this angle 11. And make a better 11 than that. Angle 11. Okay, so let's use the exterior angle theorem. Exterior angle theorem would say that measure angle 10 equals the measure of its remote interior angles, which is measure of angle 7 plus measure of angle 8. Okay? Now let's go this way further. Measure of angle 7 equals measure of its remote interior angles, which is measure of angle 4 plus measure of angle 5. And we know that the measure of angle 4 is equal to its remote interior angles, sum of its remote interior angles, which is measure of angle 1 plus measure of angle 2. Therefore, 10 has to be, from this right here, measure of angle 10 has to be greater than measure of angle 7 and measure of angle 8. Well, angle 7, measure of angle 7, has to be greater than measure of angle 4 and measure of angle 5. And we know that measure of angle 4 has to be greater than measure of angle 1 plus measure of angle 2. So, measure of angle 10, since it's greater than measure of angle 7, also has to be greater than measure of angle 4 and 5, and has to be made, and since angle 7 is greater than the measure of angle 4, it also has to be greater than the measure of angle 1 and 2. Okay? So simply from here we can say 10, measure of angle 10 is greater than measure of angle 7, measure of angle 8. Angle 7 is measure of angle 4, measure of angle 5, measure of angle 1, measure of angle 2. All right? Measure of angle 7 is greater than measure of angle 4, measure of angle 5, measure angle 1, measure of angle 2. And measure of angle 4 is greater than measure of angle 1, measure of angle 2. All we're doing is coming over here and saying, okay, what does this addition tell us? Well, measure of angle 10 is made up of measure of angle 7 and 8, then it has to be bigger than that. So therefore 10 has to be bigger than anything that would make up 7. 7 has to be bigger than anything that would make up 4. Therefore 10 is going to be bigger than what makes it up, plus whatever makes up anything that it's composed of, and so forth and so on. Seems rather complicated, but follow it, and the logic it does, it's not too hard. Okay? Now what we're going to do is we're going to come back and come the other direction. Okay, what we did was we came this way using this external angle. Now let's come this way using the other way and see what we can come up with. Okay, so measure of angle 11 equals what? Measure of angle 11 equals its two remote angles, measure of angle 2 plus measure of angle 3. Measure of angle 3 equals measure of angle 5 plus measure of angle 6. What does 6 equal? Measure of angle 6 equals its two remote angles, sum measure of angle 8 plus measure of angle 9. So angle 11 is going to be greater than all of these angles. Okay? So let's go. Measure of angle 11 is greater than measure of angle 2 measure of angle 3, measure of angle 5, measure of angle 6, measure of angle 8. Okay? Measure of angle 9. So these two, and these two. Now, measure of angle 3 has to be greater than measure of angle 5, measure angle 6, measure angle 8, measure angle 9. And measure angle 6 has to be greater than what? Measure angle 8 and measure of angle 9. Okay? You get it out of the way so you can look at it. And all we did was apply the same thing we did in the first set, except we did it in reverse. Okay? That's looking at exterior angle inequalities and just simply coming up with what angles are bigger than which ones. Now, we cannot combine the two and say, oh, well, 11 is bigger than 10 or 10 is bigger than 11. We're not given that much information in this particular problem in order to do that. All we can do is determine the other, okay, from both sides. It's an example.